Notre Dame was amongst the very first to start in nuclear physics in the US. Actually, in the 30s, it was one of the priests and a graduate student built the first tandem. They used newspaper from the South Bend Tribune and rubber to make a charging belt.
But it had its limitations, and so in the early 1940s, they built a second accelerator here at Notre Dame. It was designed to be the world's most powerful accelerator at the time, and they built it in La Fortune, which was the science building. But today we know it as the Student Union, and actually scientists from the University of Chicago involved with the Manhattan Project came to Notre Dame and used that accelerator. They were studying materials. They were designing the nuclear reactors that were going to be built in Hanford, Washington to create the plutonium that went into the Fat Man bomb.
And it wasn't until the 1950s that the Atomic Energy Commission was established to study nuclei. And I believe that was the first grant that Notre Dame had was with the Atomic Energy Commission.
The scientists here installed a much larger accelerator in about 1968. It was much more expensive, something on the order of a $2 million grant from the National Science Foundation. So the price of accelerators obviously increased drastically from $900 to $2 million approximately. That accelerator has been operating continuously since about 1970 or so. It still is being used by scientists in nuclear physics here at Notre Dame. It's still our most powerful machine that we have here. It's now joined by a couple of other accelerators. One is dedicated to nuclear astrophysics measurements called the 5U accelerator, and we also have the 9S accelerator, which is geared towards nuclear applications.
And now I would say we are probably not only the best recognized, but the best place for nuclear astrophysics in the world.
And training of students has allowed us to not only keep this facility going, but actually increase it enormously. I mean, we are now a facility, about 60 people work here day in, day out. We have 33 graduate students.
We led the effort in the United States to do nuclear astrophysics underground. So we have an accelerator in South Dakota in a gold mine that's 4,000 feet below sea level. When I came to Notre Dame, there were 34 universities that had laboratories like ours with accelerators. There are now 5, and it's not by just coincidence that that has happened.
There are a number of people that really fought very, very hard to keep these types of facilities here at Notre Dame. People like Jim Collada, Connie Brown, and then other colleagues came up with how do we position these laboratories in such a way that we can keep them going.
We have identified science that we can do at Notre Dame that is outstanding, and we have really excelled in nuclear astrophysics.
But we're also looking at what are the big problems of society. What we see now is there is an enormous disbelief between society and what science is bringing. What we have to do now, and what Notre Dame is really well placed at, is how do we train that next generation to communicate what we are doing, why it is important, and why it's worth trusting scientists. Why is science so important?
The Institute for Structure and Nuclear Astrophysics, as it is now called, celebrated 80 years of nuclear physics study at Notre Dame. We would not be where we are today without the support of our students, as well as the incredible trust and financial support from the University of Notre Dame and the United States National Science Foundation.